Okay, welcome back. This lesson is about the area of a circle, but more specifically, just part of the circle. So when you studied this in the 7th grade standards, whatever year it was that you took that, you were taught that the area of a circle is A equals pi r squared. So that's what I wrote down there for you in case you've forgotten. And there were problems back then that even you had to find the area of part of a circle, but it was usually half of the circle. So you would find the area of the entire circle and then divide your answer by 2. And this section is basically the same thing as that, except we're not going to be dividing the circle by 2 at most times. It's going to be a more complicated fraction than that. It'll be like a 30-degree piece of the pie instead of a 180-degree piece of the circle. All right, so this is your basic review for area of a circle. If you have a radius that's 2 inches, you square the radius, so you get 4. 4 times pi inches squared. If it says leave your answers in terms of pi, then you're done. If it doesn't, you have to use 3.14 for pi, and that's what I've done. I've multiplied 3 times 3.14, and that's how I got 12.56 inches squared. So that's your basic review on area of a circle. Now, here's a problem for area of part of the circle. Usually when they want you to find the area of part of a circle, they'll shade in the section that they want you to find. So in this case, I shaded in what would be basically the first quadrant up there. And I gave you 3 pieces of information about the circle. A is the center. That's very important. This shaded region has to connect to the center. If it doesn't, then the problem becomes much more difficult. So lucky for you, the vertexes are all going to be at the center. All right. The angle BAC is 90 degrees. You can also see that from the picture because I wrote the right angle mark in there. And then AC, otherwise known as the radius, is 3 inches. So we square the radius. This is our formula, sector area. Sector is part of the circle. So sector area is pi r squared. That's the formula for the area of the whole circle. So that's the strategy. Find the area of the whole circle and then multiply it by the fraction that we're interested in. And the fraction that we're interested in is always going to have 360 as its denominator because there's 360 degrees in the circle, and we just want to know what is the area of 90-degree portion of that. So 90 out of 360 reduces to 1/4. So we're basically trying to find the area of 1/4 of this circle. So it's 9 pi times 1/4, which if you leave it in terms of pi, it's just 9 pi times 1, which is 9 pi for your numerator. 1 for your denominator underneath 9 pi times 4, the denominator in the second fraction. So you get 9 pi over 4 inches squared. And if you have to convert that into an actual number, then you multiply 9 times pi and then divide that by 4, and you get 7.065 inches squared. So that's it. This standard, the students did pretty well on last year. It's not super complicated. Now, there are a little bit trickier types of problems, and I am going to make a video tomorrow, and it is going to be for one of those specific types of trickier problems, which is they give you the area of the sector and they want you to work backwards and use some algebra to move your formula around to solve for the radius or to solve for the central angle. So those can get a little bit trickier, but we'll get into that more tomorrow. For today, I want to give you the next level of tricky problem, which is a circle that has 2 sections that are shaded in. So I gave you that AD and BC are both diameters. That way you know they're straight lines and you can use vertical angles here. You're going to have to use the vertical angle theorem and the linear pair theorem to figure out what is that angle in those shaded regions. Well, they're going to be the same because they're vertical angles. So whatever the angle is on the bottom shaded region, the angle is going to be the same on the top shaded region. So I went ahead and added in those little marks there which say that those angles are equal, which hopefully you remember because they're vertical angles. So what is the measure of that angle? It's 80 degrees because it makes up a linear pair with the 100-degree angle. So they have to add up to 180 degrees. So that central angle in each region is 80 degrees, which hopefully you can read that because I wrote it right over the top of my shaded dash marks. So they're both 80 degrees. So we're finding the area of a section that's 80 degrees and then doubling it. So I'm going to double it right off the bat and saying that we're going to find the area of a section that's 160 degrees. Then I don't have to worry about multiplying by 2 at the end. So now that I'm going to try and solve this, I realize that I did not give you the radius for this problem, which is important. If you don't have the radius, you're missing a piece of the puzzle here. You're not going to be able to solve for any area without the radius or the diameter. So I'll tell you that AD has a length of 20. So AD is 20. We'll stick with inches. Now, some people are going to say, all right, plug that into the equation and 20 squared, and they'll get 400 pi for their area of the whole circle, and that will be incorrect because AD is a diameter. So be careful on the information that you're given. You have to find out what the radius is. So if you're given the diameter, you have to split that number in half. So your radius is actually 10 in this problem. So it's 10 squared times pi times the fraction of the circle that we're interested in, which in this case is 160 out of the 360 degrees, the 80 plus another 80. So 10 squared is 100. So you have 100 pi times, can you guys reduce that? If you're going to reduce a big number like that, they both end in 0, chop the zeros off, so then it's 16 over 36. And then you can see that 4 goes into both those numbers, so it'd be 4 over 9. So that reduces all the way down to 4 over 9. So we have 100 pi times 4/9. Now, I'm not going to take this one all the way to the end. I'm going to leave it in terms of pi because I don't feel like doing that multiplication without a calculator, but you guys are allowed to use calculators. If we were taking this test in class, you could use a calculator on it. So please, you feel free to use a calculator at home if you weren't already. But for this exercise, 400 pi over 9. Now, does that reduce? Does 400 over 9 reduce? Well, just like the trick with threes, you can add up the digits in 400, and if they're divisible by 9, then that number is divisible by 9. I hope that is correct information. That definitely works with 3. Yeah, it works. All right, so 4 plus 0 is 4. 4 is not divisible by 9. It is 4 is also not divisible by 3, so this 400 over 9 does not reduce. So that would be your final answer. 400 pi over 9 would be the area of both of those shaded regions. All right, that should be enough information to get you through the homework for today and tomorrow, really, but I'm going to do another video tomorrow to show you a tricky type of problem that you might see in the future.